We now move on to the next topic, which is LCM, which stands for the least common multiple or the lowest common multiple, and HCF, which stands for highest common factor. Now, here you can say either the lowest common multiple or least common multiple. Either is fine. Okay. So the least common multiple is the smallest common multiple of the numbers. The smallest number that will divide by all the numbers asked in the question. So another way of looking at LCM is when you generate the times table of any number, the first number in their times table where they look the same. Okay. Then we have the highest common factor. The highest common factor is the greatest divisor that divides each of the integers. The largest number that will divide into all the numbers asked in the question. Okay, so there are a few methods of finding the least common multiple and the highest common factor. We will explore three of these methods. So method number one for finding the least common multiple and the highest common factor. Let's take an example. Example 08. We have find the LCM and the HCF of the numbers 12 and 18. Okay, so first thing we do is write out the multiples of 12 and 18 until we see a common number in the answer. Okay, so let's do that. So we do 12 times 1 equals 12, 12 times 2 equals 24, 12 times 3 equals 36, 12 times 4 equals 48, 12 times 5 equals 60. It's always good practice to just do the first 5, okay? And if you do the first 5 first, and of both numbers, and then if there are no similarities, then do the next 5, okay? Just to save you some time. Then we have 18 times 1 equals 18, 18 times 2 equals 36, 18 times 3 equals 54, 18 times 4 equals 72, and 18 times 5 is equal to 90. Now notice here, when we're looking at the solutions, there is a match. So we have a common number, which is the number 36, appear in both of these numbers when we take the multiples. Okay, so what does that mean? This means that the number 36 is the least common multiple of the numbers 12 and 18. We can also write this as LCM open brackets 12 minus 18 is equal to, close brackets, is equal to 36. Okay. Now for the common factor, what we need to do is write out the factors of the numbers 12 and 18. So what are the factors of 12? What are the so find out all the numbers when multiplied together that equals 12. So let's start with 1. So we do 1 times 12 is equal to 12. 2 times 6 is equal to 12. 3 times 4 is equal to 12. And after that, we repeat ourselves. We get 6 times 4 equals 12. We get, my apologies, 6 times 2 equals 12. Or actually, we get 4 times 3 equals 12. So once we repeat, that means we stop. That means we have reached all our factors. So we've exhausted the method and we've found all our factors. Okay, so the factors are 1, 2, 3, 4, 6, and 12. Okay, what are the factors of 18? So we do 1 times 18 is equal to 18. 2 times 9 is equal to 18. 3 times 6 is equal to 18. Now the next number would be 6 times 3 equals 18. So we would have repeated ourselves. So 3 times 6 and 6 times 3 is the same. It's the same thing. We get the same answer. So we would stop and we would write down that all the factors of 18 are 1, 2, 3, 6, 9, and 18. Okay. Now going through the factors, we see that the largest factor common in both of these numbers is 6. Therefore, the highest common factor of the numbers 12 and 18 is 6. Another way to write it is HCF open brackets 12, 18 close brackets is equal to 6. Okay. Let's look at method number 2 for finding the least common multiple and the highest common factor. So let's look at the same examples again, just for the sake of consistency. Okay, so you can see how different methods vary. So we have find the highest common factor and the lowest common multiple of the numbers 12 and 18. So this method involves the trees. Okay, so what we do, we draw true nodes and we have the numbers on each node, 12 and 18, and we break them down. So in order to find the prime factors, so we do 12 divided by 2 equals 6. So in other words, 6 times 2 equals 12. And for 6 divided by 2 equals 3. So we notice here at this point, we can't break it down any further. Therefore, these are the factors, prime factors of 12. For 18, we see, okay, 18, we could have just divided by 2, but in this case, we divide by 3. So we have 18 divided by 3 is equal to 6. And 6 divided by 2 is equal to 3, or 6 divided by 3 is equal to 2. You could do either is fine. And notice here, we have the prime factors of 18, which are 3, 2, and 3. So at this stage, color the common prime numbers in both trees. So we can see that in both trees, there is a 2, and in both trees, there is a 3. Okay? Now, what we do is we draw two circles, two intersecting or overlapping circles, let's say. This is actually an example of a Venn diagram. You'll explore Venn diagrams when we do statistics later on in the course. But for now, just think of them as two circles representing each of the numbers. So the blue circle represents 12, the 18, and the orange circle represents the number 18. And they overlap each other. So the overlapping part is where the numbers appear in both of the trees. Okay? So if we go back here, we see that for 12, we have 2, 2, 3, and for 18, we have 3, 3, 2. So what does that mean? So we have 2 and 3 appear in both trees, and we are left with an extra 2 in the tree involving 12. And for the tree that represents number 18, we have a leftover of 3. Okay? So from this diagram here, we can conclude that the highest common factor is the green region, which is the overlapping region, and the lowest common multiple are all the numbers inside both the circles multiplied. Okay, so the highest common factor are the numbers inside this green part, which is 2 times 3. So we'd write that as, we could write it as 2 times 3 equals 6, or we could write it as HCF 12, 18, which equals 6. And for the lowest or least common multiple, we write all the numbers, so that are in both of the circles, including the overlapping part. So we have 2 times 2, 3 times 3 times 3, which equals 36. Yeah. So a better way of writing this is in index form, which is 2 to the power of 2 times 3 to the power of 2, which is 4 times 9, which is equal to 36. So the least common multiple is indeed 36, which confirms the answer that we got from using method number 1. Okay, so hopefully that's not too bad. Now let's look at another example. Example 9. Find the highest common factor and the least common multiple of the numbers 120 and 144. So using this second method. We have two trees. Now let's break it down, break each of them down. So 120, well, the easiest thing to do, because it has a 0 at the end, we could just divide by 10. Okay, so that means 120 divided by 10 is equal to 12. So 12 times 10 equals 120. And then each of them, so we do 10, well, 5 times 2 is equal to 10. And notice here, 2 and 5 are prime factors, so we can't go down any further in this tree. For 12, we could break it down to 6 and 2. And for 6, we could break it down to 2 and 3. So all the factors, prime factors of 120 are 2, 3, 2, 2, 5. For 144, we do exactly the same thing. If you want to, you could divide by 2, but if you know your timetables, then you know that 12 times 12 is equal to 144. So and for each 12, you could break it down. So 12 divided by 2 equals 6. So you could do 2 times 6. And on this branch, you could do another 2 different factors. You could do 3 times 4, which is also equal to 12, just for the sake of variety. Okay. Then for 6 will break down into 2 and 3. And here, 4 will break down to 2 and 2. So we have 2, 2, 3, 3, 2, 2. Okay. Can't break it down any further. Therefore, what we do, let's input this information into 2 circles. So we have a blue circle representing 120 and orange circle representing 144. So let's write down, well, first of all, let's fill in everything inside this green overlapping region. So overlapping represents it's in both of these trees. So we could cross them out if you want. So we have 1, 2 here and 1, 2 here. So we could cross this 2, cross that 2, put that 2 in here. Then we have this 2. So we cross this 2, cross this 2, put that 2 in here. Then we have another 2 here. So we cross this 2, cross this 2, and we put that 2 in here. Then we move on to the next number, which is 3. So we cross this 3, come here, cross one of the 3s, put a 3 in here. What are we left with? We are left with number 5, the factor 5, but there is no factors here of 5. Therefore, we leave that 5 outside the overlapping region, just in the blue region here. Similarly, we look at the right tree. Now we've used up all the numbers. Now look at the right tree and see that, okay, what numbers are left? So this is gone, this is gone, this is gone. This 2 is also gone. So we have a 3 and a 2 left over that wasn't included into the green region. So whatever's left over, we write it in the orange region, which is 2 and 3. Okay. Now from this, now we can, using this information, we can obtain our answer, which is to find the highest common factor. Well, the highest common factor is just the green region here. So what's inside the green region? We have 2 times 2 times 2 times 3. In other words, we have 2 to the power of 3. In other words, the 3 2's multiplied by 3, which is equal to 8 times 3, which is equal to 24. So the highest common factor of 120 and 144 is 24. The least common multiple, what is the least common multiple? We multiply everything inside the circles, okay, including this region. So we have 1, 2, 3, 4 2's, so 2 to the power of 4. We have 1, 2, 2 lots of, so we have 3 to the power of 2 multiplied by 1, 5. So multiplying all this together, we get 2 to the power of 4 is equal to 16. 2 to the power of 3 to the power of 2 is equal to 9. And then we have 5. So 16 times 9 times 5 is equal to 720. Therefore, the least common multiple of 120 and 144 is equal to 720. Okay, so that was method number 2. Now we move on to method number 3 for finding the least common multiple and the highest common factor of two numbers, or of some numbers. Okay, so let's look at example number 8 again. Now that was that involved finding the LCM and the HCF of the numbers 12 and 18. So what is the third method? So this method involves a table. So first we need to draw a table with both of the numbers and start dividing by one of the prime numbers, 2, 3, 5, or 7. Okay, that divides exactly into that number. So let's see. We have our table. We have number 12 there, which is one of the numbers, and 18, which is the other number. So first thing we do, okay, we notice that, okay, let's just work with 12 for the time being. 12 is an even number. So out of these 4 prime numbers, 2 is an even number. 2 will divide into that. 3 will also divide into 12. But let's just work simply. Okay, let's just work with 2. So 12 divided by 2, we do that first. What do we get? Our answer is 6. So 12 divided by 2 is equal to 6. Now we do the same thing again. 6, what can we divide 6 by? Let's try one by one. So let's try with 2 first. So 6 divided by 2. Does 6 divide by 2 exactly? Yes, it does indeed. So 6 divided by 2 is equal to 3. Now 3 divided by 2, well, that doesn't really go in. So 2 doesn't go in exactly into 3. So we go into the next number, which is 3. So we do 3 divided by 3, and we get the answer 1. Once we get the answer 1, then we stop. Okay, that means we have our answer. Let's do the same thing with the number 18. So we have 18. Let's start with the first number. So 18 divided by 2, does it divide exactly? Yes, it does. So 18 divided by 2 is equal to 9 with no remainders. So let's do it again. So let's do 9 divided by 2. Well, if we do 9 divided by 2, it leaves remainders. So we can't use 2. Let's try the next number, which is 3. So 9 divided by 3 is equal to 3. Okay. Then we do it again. So 3 divided by 2. Well, we know that we can't do that because it leaves fractions. So we do the next number, which is 3 divided by 3. Which equals 1. Now that we've reached 1, that means we have our answer. So, how do we interpret this? So the way we would interpret it is we would look at both of these columns, okay, and we would write down for the first number 12. 12 is equal to 2 times 2 times 3. Another way to write that is 2 to the power of 2 times 3. And 18, we write down as 2 times 3 times 3. Basically, just numbers in these columns. Okay. Another way, just tidy it up. So you get 2 times 3 to the power of 2. Now, how do we determine what's the highest common factor? To obtain the highest common factor, we look at the number, the highest number that appears in both of these. Okay. So notice the highest number is, in highest numbers. So let's just look at 2. 2 appears twice for 12, but only appears once for 18. So we only write once because 2 goes into both. 2 is, there's 2 lots of 2's there and there's 1 lot of 2 there. Therefore, 2 is going into both of them at least once. So we write down 2 here. Then we have 3 squared and 3. Well, we have at least 1 3 in both of them. So we write that down, then we multiply them. So it's 2 times 3 is equal to 6. Therefore, the highest common factor of 12 and 18 is 6. How about the least common multiple? Well, for the least common multiple, what we do is we look for the largest number, largest factor that appears in both of them. So number 2, so 2 squared is the largest of the 2. That appears in both. Of the 2 is the largest, so we write that down, 2 to the power of 2. And 3 squared is the larger of the 2, wherever 3 appears. So we write down 3 squared, and we multiply the answer. So it's 2 squared multiplied by 3 squared, which is equal to 4, multiplied by 9, which is equal to 36. And so we could write it as the least common multiple of 12 and 18 is equal to 36. And notice indeed, these are consistent with the solution that we obtained for methods 1 and methods 2. Okay. Excellent. So let's look at another example. We have find the least common multiple and the highest common factor of the numbers 24 and 48. So same again, we start by drawing out a table with the two numbers. So we have 24 and 48. And then we start dividing the numbers by the prime numbers 2, 3, 5, and 7. Okay, so 24 divided by 2, we get 12. 12 divided by 2, we get 6. 6 divided by 2, we get 3. 3 divided by 3, we get 1. So we reached 1, so we stop here. Then we look at the next number, 48. So let's divide by 2 again. So we go 48 divided by 2, we get 24. 24 divided by 2, we get 12. 12 divided by 2, we get 6. 6 divided by, well, we could have done 2 as well, but we do 6 divided by 3, gives us 2. 2 divided by 2 gives us 1. Okay, notice that if we did divide by 2 here, so 6 divided by 2, we would have got 3, and then we would have done 3 divided by 3, get 1. We would have got exactly the same answer. Okay, just in different positions. Okay, so now what we need to do is we need to write down all the factors and multiply them together. So we have in the 24 column, we have sorry, I should say the column next to 24. We have 2 times 2 times 2 times 3. Okay, so that's 2 to the power of 3 multiplied by 3. And then in the column next to the number 48, we have 2 times 2 times 2 times 3 times 2. So that's 2 to the power of 4. There's 4 2's and there's 1 lot of 3. Okay, so the highest common factor. So the highest common factor is the largest factor that goes into both. So notice here there is 1, 2, 3 2's here, there is 4 2's here. So the largest number of 2's that are in both of these is 2 to the power of 3. In other words, there's 2 to the power of 3 in both. Okay, and we see what's the largest number of the second factor. So there's only 1 lot of 3 in both. So we do 2 to the power of 3 times 3, so it's 8 times 3, which is equal to 24. So the highest common factor of 24 and 48 is 24. Then we look for the least common multiple. So that is the largest factor of both of these numbers. Okay, so the largest number is 2 to the power of 4. And the largest number of the second factor, 3, is just 1. So it's 2 to the power of 4 times 3 is equal to 48. So the least common multiple of 12 and 48 is 48. Okay. So notice that we could also write it out in the form that's shown previously. So HCF open brackets 24, 48 is equal close brackets is equal to 24, and LCM open brackets 24, 48 close brackets is equal to 48. Okay, let's look at another example. Now, we up until now we've only seen how to find the least common multiple and the highest common factor of two numbers. But it's not limited to just two numbers. Maybe the second method involving the two circles, because if you add a third circle, it just complicates things a little bit, but not by a great matter. But yeah, but we could also use it to find the LCM and the HCF of more than two numbers, three numbers in this case. Okay, so let's look at this example. Right, so we just do let's apply the third method, okay, as we are working on it. So the third method, so we have a table with our numbers of interest, which are 30, 45, and 150. Now notice we notice that the largest of the prime numbers 2, 3, 5, 7 that goes into all of these, it is the number 5. So let's do that. So we do 30 divided by 5, we get 6. 6 divided by 3 gives us 2. 2 divided by 2 gives us 1. So we stop. Then for number 45, we have 45 divided by 5 gives us 9. 9 divided by 3 gives us 3. 3 divided by 3 gives us 1. And then we have 150 divided by 5 gives us 30. 30 divided by, we could have just done 5 again, but we did divide by 3 gives us 10. 10 divided by 5 equals 2. 2 divided by 2 equals 1. So we stop. So now we need to find the, we're writing the prime factors of each of these numbers. So the prime factors of 30 are 5, 3, and 2. The prime factors of 45 are 5, 3, and 3. The prime factors of 150 are 5, 3, 5, and 2. Okay. Now the highest common factor. So the highest common factor is the number, the largest number, or the numbers, out of the factors, so that's 5, 3, and 2 are factors, so that appear in all of them, the frequency, the number of times, the largest number of times they appear in all of them. So we see in the first, for the first number, we have 5, 3, 2. Second number 45, we have 5, 3, 3. So we have 5, 3, 5, 3 in both. And the third one, we have 5, 3, 5, 2. So 5, 3, 5 times 3, 5 times 3, 5 times 3 appears in all three of them. Therefore, 5 times 3 is our highest common factor. Notice 2 appears in the first, for the first number and the last number, but not for the second number. Therefore, we can't include that for our highest common factor. Okay? For the least common multiple, the least common multiple is the product of the highest power of primes present in the factors. So, looking at all of these, the highest number is 5 squared. Looking at the second number, the highest power is 3 squared. And looking at all of these, we see the highest power for the final factor, 2, is just 1. So 2 to the power of 1. So we have 5 squared multiplied by 3 squared multiplied by 2, which is equal to 25 times 9 times 2, which is equal to 450. Therefore, the least common multiple is equal to 450 of these three numbers. And the highest common factor is 15 for these three numbers. Okay, so now it's your turn. So have a go at these questions and see how you get on. I would try have a go at all the methods. Have a go at solving these questions using all three of the methods. Okay, because you might find one method more easier than the other to use. Okay, so have a go at all the methods, and yeah, see how you get on tackling these questions.